Okay, today's lesson is lesson 3.3, modeling with functions. Today we're going to work on writing and interpreting functions. We're going to use function notation, and we're going to talk about independent and dependent variables. Okay, we're going to start with the vocabulary. First vocabulary word is independent variable. Make sure you check on your iPads, download the update, just make sure it's running. Okay, an independent variable, that's the input of a function. Or we say it's the x, your independent variable. And you guys did independent and dependent last year in 8th grade science. So this should just be a kind of a review. Next vocabulary word, dependent variable. The dependent variable is the output of a function, or the y value. And then the last vocabulary word for this lesson is function notation. Function notation is, it's another way to write equations. For example, in slope-intercept form, we might write y equals 3x plus 2. In function notation, we just change the output, the dependent. It becomes f of x. And then you just write the equation. So this way of writing your equations, this is called function notation. You will use this a ton over the next 4 years. Okay, then let's move on to example 1. Example 1 is going to ask us to identify the dependent and independent variables. So it's going to give you a sentence, and you have to say which words are the dependent, which words are the independent. Okay, 1A. In the winter, more electricity is used when the temperature goes down. And then less is used. In the winter, more electricity is used when the temperature goes down. Also, we're not talking about Arizona here. Arizona's flipped on this. I'm from Chicago. In Chicago, during the winter, we use more electricity when the temperature goes down because we're putting the heater on. And less, where's the word problem? And less is used when the temperature rises. I'm going to put temp. Like, there's many people that don't have air conditioning. My uncle did not have air conditioning in his house. There were some days when it was super, super hot, but more often than not, it was okay without. I mean, now it's getting really, really gross, but. So here we have a situation. We have to determine what's independent and what's dependent. So here's a little clue, a little sentence you're going to write each time to help you to figure out what's independent, what's dependent. So everybody write this down. The blank depends on the blank. So when we think about this situation, I want to figure out what depends on something else. So the two things we're comparing are the amount of electricity used and the temperature outside. So I need to figure out, does the electricity used depend on the temperature, or does the temperature outside depend on your electricity used? So you kind of have to use a little bit of common sense here. Clearly, the temperature outside, it's not waiting to rise depending on if you turn your electricity on. That wouldn't make sense. It is we use more electricity depending on the temperature. So we'll put electricity on the first line, because the electricity we use depends on if it's hot out or if it's cold out. So it depends on the temp, or the temperature. So it says the electricity depends. So that means that's going to be our dependent variable. So we'll need to list out our independent variable and then our dependent. So the electricity depends on this. So that means electricity is your dependent. The electricity that you used. And again, this should be a review from 8th grade science. You guys did dependent and independent. And then your independent is temperature. The temperature outside is just going to change. It's not waiting to figure out how much electricity you're using. It's just going to go up and down. So it's independent. Okay, let's try another one like that. So you're going to get a word problem. Write down this sentence to help you. The blank depends on the blank. And then that'll help you determine what's independent and dependent. Okay, 1B. The cost of shipping a package is based on its weight. So most of you realize, like, if you have to go mail something, the heavier it weighs, you have to pay more money. Okay, so write down the sentence. The blank depends on the blank. So this sentence will help you determine which one's dependent, which one's independent. Okay, so think in your head, does the cost depend on how much it weighs, or does the weight depend on how much it costs? So it's going to be the cost depends on how much it weighs. Your weight of your package isn't going to fluctuate. It's not going to change depending on how much you want to spend. So the independent is weight. Remember, it says the cost depends. So cost is your dependent. Okay, then you're going to try one on your own. The total cost of running a business is is based on its expenses. The total cost of running a business is based on its expenses. So first, figure out the blank depends on the blank. And then determine what's independent variable, what's dependent. Okay, go ahead and work on that one. Cost depends on expenses. So independent is how much expenses your business has, and the dependent is your total cost of running it. Okay, let's move on to example 2 now. Example 2 is going to ask to write each function, write each equation in function notation. So write yourself a reminder, this means solve for y. When you get these equations, you need to get y isolated first. So here's our first one, letter 2a. 3x plus 2y's equals 12. Everyone should be taking notes, not just sitting there watching me do this. Okay, last year when you guys had to solve for y, when you had to put things into slope-intercept form. So you've done this 1,000 times. So we have to first get this equation solved for y. So draw your line going down from your equal sign. Look at the side that has the y. Right now, there's 2 terms there. If it helps, put a box around each term. I have a positive 3x and I have a positive 2y. Keep in mind, the positive or the minus, it goes with whatever's behind it. So when you circle or box terms, don't forget to include the symbol. Okay, look at the side that has the y. We're trying to get y by itself. Get rid of the other term that's not the y. That's a positive 3x. To get rid of a positive 3x completely, we're going to subtract 3x. If I subtract 3x's from one side, I have to do it from the other side. That's the subtraction property of equality. Everyone needs to be paying attention right now. 3x's take away 3x's. No more x's. I still have positive 2y equals, okay, these two things do not go together. These are not like terms. So the number 12 and 3x's don't go together. This does not equal 9x. These are 2 different things. I typically want things in slope-intercept form, so I always put my x's first out of habit. You can put 12 minus 3x. That's fine. I always put my x's first, though. There were no x's, and then I took away 3x's, so I have negative 3x's. There's the number 12, so it's a positive 12 since there's no symbol. When there's no symbol, it's positive. Okay, look at the side that has the y. Right now it says 2y. When things are touching, it means multiply. So to get rid of multiplying by 2, we divide by 2. That means we divide everything by 2. Or you can draw one big fraction bar. 2 divided by 2 is just 1. So I have 1y. Negative 3 over 2 is just negative 3 over 2x. 12 over 2 is just positive 6. Okay, now to make this function notation, all you're doing is changing the y into f of x. I'm going to rewrite this just because I'm kind of running out of space. I should have gone to another page. So this says y equals negative 3/2 x plus 6. To put it into function notation, you just change the y into f of x. F of x, and we always do like a fancy f, equals negative 3/2 x plus 6. Okay, let's try another one. This is 2b. 4y minus 2x equals 16. Draw a line going down from your equal sign. You should be taking really good notes. Look at the side that has the y. Right now there's two terms there. There's a positive 4y and then there's a minus 2x, right? So get rid of the other term that's not the y. Instead of subtracting 2x's, we're going to add 2x's. If you do it to one side, you have to do it to the other. That's the addition property of equality. On the left, I still have positive 4y, so bring down your positive 4y. I had negative 2x and then I added 2x's, so the x's went away. Bring down your equal sign. These don't go together, they're not like terms. Do not write 18x. These do not go together. I typically put things into slope-intercept form, so I put my x's first. There were no x's and then I added 2x's, so I have 2x's. I have a 16, if there's no symbol, it's positive. Look at the side that has the y. Right now it says 4 times y. To undo multiplying by 4, I'm going to divide by 4. Divide everything by 4. Okay, on the left-hand side, I have 4 divided by 4. That's just 1y. 2 divided by 4, that's a half. You can either put the fraction of a half or you can put 0.5. I'm okay with I'm okay with decimals as long as the decimal terminates. If you get a decimal that goes on forever, do not write it down. I need the fraction. Okay, then don't forget to put your x, because it's 2 over 4 x's. 16 over 4 is just positive 4. Now to change this into function notation, you just change that y into f of x. And then it's in function notation. Okay, now we're going to practice this in some word problems. Example 3. Now for these word problems, it's going to ask us to do a couple different things. It asks to identify independent and dependent variables. It's going to ask to write the equation in function notation. And then lastly, it's going to ask you to actually solve whatever the question is being asked. So for these types of questions, you're going to have to do all three things. I hope you're taking good notes right now. You have to identify independent and dependent. You have to tell me the equation and function notation, and then you actually have to solve whatever they're asking. Okay, so here's example 3a. A lawyer's fee is $180 per hour for his services. How much does he charge for 5 hours? How much does he charge for 5 hours? And then it also says to let H stand for hours. So this is important when you guys get to HMH. It's going to mark things wrong if you don't use the correct variable. If you put an X in when it wants an H, it's going to mark it wrong. Okay, so we have a lawyer's fee. It's $180 an hour. How much does he charge for 5 hours? And let H stand for hours. The first thing we have to do is identify independent and dependent. And remember, we have that sentence that helps us. The blank depends on the blank. The blank depends on the blank. You should be writing this down, especially if you're somebody who struggles in math. Okay, we're talking about how much he charges, and then hours. So those are the two things. Figure out which word goes where. Hours and how much he charges. Figure out which one depends on which. And it should be the cost or the charge, or however you want to write that. How much he charges depends on how many hours he works for you. Not while I'm teaching. So that means cost is dependent and hours is independent. So our independent variable is hours. Dependent is cost, or how much he charges. Remember, independent stands for our x, dependent stands for the y. I hope you're paying attention. This is super important for algebra. Okay, then we have to change this into function notation. So we identified independent and dependent. So here's one of your answers. Then it says to write the equation in function notation. I'm going to start by writing it just in typical using your x and y. So this is your dependent, your cost is equal to $180 times however many hours you use them for, right? So y equals 180x. However, they want it in function notation. So that's when it's f of x equals 180x. But then this is the part where people are going to get this mixed up. They want us to use h for hours. Hours is our x. So everywhere you see an x, we're actually going to put in the letter h. So your final answer is going to be f of h equals 180h. You're just changing every x into the letter h because they're talking about hours. Then the last thing we do is we actually have to solve it. So it says how much does he charge for 5 hours? So you take your equation of 180h and you're just plugging in 5 hours. 180 times 5, he charges $900. Okay, then we're going to try another one. Hold on one second, sorry. Okay, we have a carnival. The admission fee, just to get in, is $9. And then each ride is $1.75. So to get into the carnival is $9, each ride is $1.75. Then it says how much does it cost to go to the carnival and then go on 12 rides. And it says let R stand for rides. So first thing we need to determine is what's independent, what's dependent. The blank depends on the blank. So see if you can figure out what are the two things we're talking about. And then from there, see if you can figure out which one is the independent, bless you, and which one is dependent. The cost depends on how many rides you go on. So the independent variable is how many rides you're going on. The dependent is how much your total cost is going to be to go to the carnival. Then we're going to write the equation. So first, I'm going to just put it into slope-intercept form using y and x. So y equals, slope is always the thing that keeps changing per something. So that's going to be the $1.75 because every ride will be $1.75. Plus Your admission fee, that's just your beginning. That's your y-intercept. You're never going to pay less than $9. So just to get into the carnival costs $9. So there's our equation. I need to put it into function notation, so change y to f of x. And then lastly, see if they need you to use a different variable. They want us to use r for rides, which was your independent. So instead of putting x, we're going to put an r. So f of r equals $1.75 r plus 9. And then lastly, how much does it cost to go on 12 rides? So you're going to take your equation and you're going to plug in 12 for r. So $1.75 times 12, and then don't forget to add in the $9 that it costs to go on the, or to enter the carnival. So $1.75 times 12 is 21, plus the $9. It's going to be $30 to go to the carnival plus go on 12 rides. Okay, now you're going to try one on your own. Kate earns $7.50 per hour. How much money will she earn for 8 hours, for 8 hours of working? How much money will she earn for 8 hours of work? Let H stand for hours. So you're going to tell me what's the independent, what's dependent, give me the equation and function notation, and then give me the answer. Okay, hours worked and total amount that you earned. Your equation is f of h equals 750 times h. And then she earned $60. Okay, last example, example 4. Now example 4 is going to ask us to write the equation, write it in function notation. But the different thing here is it's also going to ask to find domain and range. Okay, the first word problem. It says Manuel has already sold. Manuel has already sold $20 worth of tickets to the school play. Manuel has already sold $20 worth of tickets. It's to the school play. He has 4 tickets left to sell. He has 4 tickets left to sell. He has 4 tickets left to sell at $2.50 each. Write a function for the total amount collected from ticket sales, and then it says let T stand for tickets. Manuel has already sold $20 worth of tickets, and now he has 4 tickets left to sell. They're each $2.50. Okay, we have to come up with an equation and function notation. So first I'm gonna write it in just normal using y and x to make it easy. So y equals, he has tickets that are $2.50 each. So the tickets are $2.50 for every x, for every ticket. Plus he also has the $20 that he already spent. And then we're just going to convert this into function notation. So f of x so that's function notation. However, they want us to use t, not x. So your final answer will actually be f of t equals 250t plus 20. The t, typically we make it like fancy looking just so it doesn't look like a plus sign. So look at your paper, make sure it doesn't look like a plus and a plus. It just gets really hard to read then. So here's the equation and function notation. Now we have to determine what's the domain for the situation and then what's the range for the situation. So in the situation, it says he has 4 tickets left to sell. So you have to keep in mind it has to make sense for what's going on. So your domain is your tickets, that's your x. He could sell 0 tickets because he has 4 left. He can sell none of them. He could sell 1 ticket, he can sell 2, he can sell 3, and he can sell 4 tickets. Typically when you see domain and range listed out, we put a brace around them. Okay, now for the range, it's what the total cost is going to be now. So we're going to use the equation f of t equals 250 times t plus 20. And we're going to plug in these different x values. So the first x value I'm going to try is 0. So I'm going to plug in 0 for t. So 250 times 0 is 0 plus 20 equals 20. So the first range amount will be 20. Then I'm going to plug in the 1. So 250 times 1 is 250 plus another $20 that he already earned. So now it's $22.50. Now we're going to try it with 2. So you're going to try it with every single one of these x values. $250 times 2 is $5. $5 plus 20 is $25. So 0 and 20 went together. 1 and 22.50 went together. 2 went with 25. Then next we're going to do 3. $250 times 3 is $7.50 plus your $20 makes it $27.50. And then lastly, plug in that number 4 into x. Also, I'm going to show you how to do this on your graphing calculator a lot easier. So 250 times 4 is $10 plus $20 is $30. And then we typically put a brace around them. Okay, if you have a graphing calculator, pull it out. I'm going to show you how to do this way easier. Okay, in your graphing calculator, press the y equals key. It's right up here. If there's anything written in there, hit clear it out. Sorry, there's going to be a glare. We're going to type in the equation. So the equation we're using, when you type it in, it has to be y equals. You can't type it in until it's in y equals format. So here it is. So 250, so $2.50, X or T. So the button that we're going to use is the X button, and it's right next to the green button. It's right here. Hit that button, it'll give you an X. So 250X plus 20. So put that into your graphing calculator. Then we're going to go into the table. The table function is right here where it says graph. It's right above the word graph in blue. So since it's in blue, you have to press the blue button first, the second key. So hit second in graph, and you'll get a table. Sorry, it's really hard to see with that glare. Okay, so if we had 0, when X was 0, Y is 20. And then scroll down. When X is 1, Y is $22.50. When X was 2, it was $25. So you don't actually have to do all of this work. You can just put the equation into your graphing calculator and use that. So if you have a graphing calculator, I highly suggest you use it. If you don't have one, I highly suggest you get one. Okay, that was that for that. We did domain right. Yes. Okay, 4B. Let's do another one like that. A telephone company charges 25 cents per minute for the first 5 minutes. The telephone company charges 25 cents a minute for the first 5 minutes, plus a 45-cent connection fee. Write a function, and it says let M stand for minutes. Not while I'm teaching, when I'm done. So the telephone company charges 25 cents every minute for 5 minutes. Plus, they're also going to charge everyone a 45-cent connection fee. So first we have to come up with the equation. So in function notation. So instead of it being y, it's going to be f of x, but they want us to use m. So it's going to be f of m the slope is the thing that keeps changing every something. That's going to be the per minute. So it's 25 cents every minute. Instead of using x, it wants us to use m for minutes. Plus there's that y-intercept, the connection fee, because that's your starting amount is 45 cents. So there is your equation in function notation. Then we need to do the domain. Okay, we're not going to include 0 because you don't get charged. If you're on the phone for 0 minutes, that just doesn't make sense. You're not going to get charged for it. So your domain is going to be 1 minute, 2 minutes, 3 minutes, 4 minutes, and 5 minutes for this. Then your range, we're going to plug in 1 into this equation and solve it. Plug 2 into this equation and solve it. Plug 3 minutes. Those of you with a graphing calculator, grab your calculator, go into y equals is right here, clear out whatever's in there, then type in the equation, 0.25, then the letter x is right next to the green key, plus 0.45. And then we're going to go into the table. The table, to get table, you have to hit second and graph. Here's our values. So for 1 minute, it's 70 cents. For 2 minutes, it's 95 cents. For 3 minutes, it's $1.20. For 4 minutes, it's $1.45. And then finally, for 5 minutes, it's $1.70. If you don't have a graphing calculator, you're just plugging in 1 for M, so do 0.25 times 1, add 45 cents. So to do all of those. Okay, last thing we're doing for today, we're going to skip, if you have the paper, skip 4C, we're going to run out of time. So go down to the on your own. And go to number 3. I'm skipping 4C just because we're going to run out of time if not. Question 3. The temperature early in the morning is 17 degrees Celsius. The temperature increases 2 degrees every hour for the next 5 hours. So the temperature starts at 17 degrees Celsius and then it's going to go up 2 degrees every hour for 5 hours. Let H stand for hours. Okay, come up with your equation and function notation. Figure out what's the domain and figure out what's the range. Go ahead and work on that. So if you go into your graphing calculator, clear out whatever's there, 2x plus 17, and go into your table. For 0, it's going to start at 17, 19, 21, 23, 25, and 27. So that would be the appropriate range for this situation. Okay, for the rest of the time, then you're going to start your exit ticket on HMH. Some of you guys are doing your updates on your iPad, so if it's still running, let it run.